Hello, calculus fans. Let's do another example of finding absolute extrema. So the function we'll try out is f of x equals x over x squared plus 1. This will be defined on the interval from 0 to 2. We want to find the absolute maximum and absolute minimum of this function. Now this function is continuous on the interval from 0 to 2, so we can use the closed interval method. So let's follow the 3 steps. So first we'll find the critical numbers. That means we have to take a derivative. Okay, so if we're going to differentiate this function, we'll use the quotient rule. Low d high minus high d low, square the bottom, and away we go. So we should get something that looks like this. Now ordinarily, we like to say, don't worry about simplifying your derivative. But that only crops up in cases where we're not going to do anything further with the derivative. Here we are going to do something more with the derivative. We're going to try to see where the derivative doesn't exist and where the derivative is equal to 0. That's what we mean by critical numbers. So let's go ahead and simplify this. So we take the x times 2x, turn it into 2x squared. And then we combine like terms in the numerator, so the numerator turns into 1 minus x squared. So we want to know, where does this derivative not exist and where is it equal to 0? Now there aren't any places where the derivative doesn't exist. Oftentimes we're looking for places where the denominator is equal to 0. That never happens here. So now we're going to set the derivative equal to 0. And we can do that by just setting the numerator equal to 0. And that's where we get this 1 minus x squared is equal to 0. If we solve that equation, then we're going to get x is equal to plus or minus 1. Now remember, we're only interested in the interval from 0 to 2, so we can actually ignore x equals negative 1. So the only critical number we get is x equals positive 1. So our next step is to plug in the values that we get for the critical numbers, our one critical number, along with our 2 endpoints. So we're going to plug in 0, 1, and 2 back into the original function. Now we're done with the derivative. Let's not plug anything into the derivative. We want to plug it back into the original function, this guy right here. So we plug in our values. So these are the endpoints. And this is the critical number. We plug those in to see what we get. So now what we need to do is, once we have these outputs, we're going to see which one is biggest, which one is smallest. That's our final step. Now it's pretty easy to see that 0 is the smallest output. And then with a little thought, you can see that 2/5 is less than 1/2. That's because 2/5 is 0.4 and 1/2 is 0.5. All right, so we know then that the absolute minimum is 0. That's our smallest output, and it occurs at 0. And then 1/2 is the absolute maximum, and that occurs at 1. 1/2 is the biggest output that we get, and it occurs when we plug in x equals 1. Okay, that's all for now.